Hello everyone, welcome to the Pearl Identification course. In this series, we will introduce you to the basic knowledge about pearls and equip you with the skills to accurately identify them. To access the complete course, please click the link in the comment section. In our first lesson, we will dive into the fascinating process of how pearls are formed. Let's get started. The formation of pearls typically begins with an unexpected external stimulus. When a mollusk opens its shell to breathe or feed, a tiny foreign object, such as sand grains, parasites, debris, or other microscopic organic materials, may accidentally enter its body, especially the soft tissue layer known as the mantle. Once the mantle is stimulated by the foreign object, as a defense mechanism, epithelial cells from the mantle begin wrapping this foreign object. Some epithelial cells migrate into the connective tissue of the foreign object, forming a layered structure around it, known as the pearl sac, which eventually results in a pearl. The cells within the pearl sac continue to divide, proliferate, and secrete a special material known as nacre. Nacre is composed of calcium carbonate, primarily aragonite, and protein, giving pearls their unique luster and color. The secreted nacre gradually accumulates around the foreign object, forming concentric layers tightly packed together like rings of a tree. Each layer of nacre is extremely thin, but as the secretion process continues, these layers increase, gradually making the pearl larger and more solid. The color of pearls is determined by various mechanisms, one of which is the protein pigments present in the mother oyster. For instance, if the protein pigment in the mother oyster is yellow, the pearls produced will be similar to Akoya pearls or freshwater pearls, exhibiting light hues like pale white, cream, or light pink. Pinctada margaritifera contain pigments in red, blue, and yellow hues, which enable them to produce the rich and vibrant colors of Tahitian pearls. Nucleated pearls. If the foreign object acts as the nucleus, the resulting pearl is called a nucleated pearl. Non-nucleated pearls. In some cases, pearl formation does not result from an external foreign object. Instead, it is caused by internal mantle tissue abnormalities, such as cell protrusions or tissue damage, which trigger nacre secretion. Pearls formed in this way lack a distinct central nucleus and are referred to as non-nucleated pearls or natural non-nucleated pearls. Over time, the nacre within the pearl sac continues to accumulate, ultimately forming a pearl with a certain size, shape, and luster. This process may take months to several years, depending on factors like the type of mollusk, growth environment, and the nature of the foreign body stimulus. The formation of a pearl is a complex and intricate process, representing a biological defense reaction by mollusks to external stimuli. Through the orderly work of mantle epithelial cells, nacre is secreted and layered, eventually creating these precious gems. Whether it is a naturally occurring wild pearl or a cultured pearl, the basic principles of formation are the same. However, under controlled conditions, humans can precisely manage the stimulation source and farming environment to improve the quality and yield of pearls. That's all for today's video. Thank you for your attention.